So for this, we had to import the ArrayList Java util to make it all work. But anyways, the first thing I do is I define a max value, integer max value as infinite, so we can put all the infinite edges. And then we define our matrix for the tree traversal, where infinity represents there's no connection between them. And then obviously we have the singular -4 for the one path that's negative. So next thing we did was create a main, and what we do here is I have two array lists that store the paths and the costs, which as you can see from my results already showing, we use that to store all the costs and all the paths as we go through so that I can print them all in the end. And then we call find all cycles, which is the method used to call the depth first search that I use to basically do the entire thing. Next thing we do here is we have a for loop that just prints out each individual path and its cost, and then we have this statement that just takes the path.size to print the total number of cycles, which is right here, 26. And then we do this loop here to loop through our array list and see which one had the lowest cost, and then we print out that index. So going to our find all cycles, which was called earlier, all we do is send it the graph and then those two array lists, and we loop through, and we're going to call the depth first search from I, so 0 to the graph length, and we will create a new Boolean array v, which will come later every time we do that. And so basically the reason I'm doing depth first search was I started with Floyd Marshall, and I used the same one for this exercise 10, tried both of them, and I could get -2, and I used AI to bug check that, and it should have been -1, and it got to a point where after a few hours of continually checking, I just had to change the entire method I was going with because I was off by 1 the entire time. So that's how we got to this. So our depth first search is going to take in a lot of things, but basically all that matters is we set the visited current node, which is our Boolean, to true, so that we don't check the same ones multiple times. And I changed this once, and you get like 1 trillion different results, so that's why you don't do that. And then we do this path plus equals. So this is basically going to adjust our path for that specific one. So as you can see, AEDA, for example. And what we do is we add a character to this this array list, and we use this char a plus because of something we learned last year, where if you add a number to a char, it will adjust that in the, I believe it's ASCII. So a will become something different based on the current node we're at. So if we're at node C and we add that value to it, a becomes C. So then we have a loop here to loop through 0 through all the possibles, so the graph.length, and we check first, is it a edge? So if it is infinite, if that is the truth here, if we have infinite, then it is an edge. So we are looking for it not to be. And we go through and we set the new cost, create a new cost, where we just add what our cost was, which is once again one of the things we receive and we call it. And we take the current, the graph current and next, and we take the cost from where it's currently at and add them together. And then we check to make sure, has it created a full cycle, so is it back to the start, or has it not gone anywhere, we're at the same place? If that's not the case, then we add this new path, and we once more do the same thing with the character and a and start, and then we add that cost to the new costs. Then we have an else if check to say if the not visit is true, so if there's more branches to visit, then we recall depth first search with that in mind, with the new cost, and pretty much everything else stays the same. And then we come to the visited current, and we set that to false so that we can revisit current in different iterations. As you can see, if we run it, we get to the 26 results, and our minimum cycle is AEDA, and the cost is a -1. So that is our project.